Hello everyone. In this video, we will talk about how to sequence jobs at a workstation and learn how to implement first come, first serve sequencing method. One of the ultimate goals in manufacturing is to ensure that all customer demands are produced on time for the lowest cost possible. As most resources in a production facility have limited capacity, it is common to have multiple jobs in the queue waiting to be worked on by those resources. One of the challenges faced in the creation of the schedule is finding the order in which jobs are to be worked on. Job sequencing rules exist to assign priority to each job to determine which jobs should be done first. This process addresses potential scheduling issues that may lead to a lack of efficiency. The quality of a schedule can be judged in various ways. Two commonly used performance measures are flow time and past due. Flow time is the amount of time a job spends in the service or manufacturing system. Flow time is sometimes referred as throughput time or time spent in the system including service. For a set of jobs to be processed at a single workstation, a job's flow time is equal to the finish time plus time since job arrived at a workstation. When using this equation, we assume for our convenience that the first job scheduled starts at time 0. At time 0, all the jobs were available for processing at the workstation. The second measure that we used is the past due measure. The measure past due can be expressed as the amount of time by which a job missed its due date. We can also refer to this one as tardiness or as the percentage of total jobs processed over some period of time that missed their due dates. Minimizing these past due measures support the competitive priorities of cost, quality, and time. Now, there are many job sequencing rules that can be used. For example, first come, first serve, earliest due date, and shortest processing time. We will focus on first come, first serve method in this video. The first come, first serve sequencing method processes orders in the order of their arrival at their production facility or resource. The arrival time is a key component and factor within the job sequencing rule, which is what separates it from methods such as longest processing time and shortest processing time. This method is commonly used in production facilities as it is extremely easy to implement and there is no estimation required for the processing time length. Now let's discuss this first come first serve rule with an example. In this example, we have 5 jobs in this problem and we are required to sequence these jobs according to first come first serve rule. Once we arrange the jobs according to first come first serve rule, we will calculate average days past due and average flow time. We have the information about the time since order arrived, the processing time, and the due date for each job. According to first come first serve rule, job A will be the first one in the sequence since job A arrived 15 days ago. Using the same approach, job E will be the last job to process since it arrived today, means 0 days ago. The start time for job A will be 0. Job A will take 25 days to process and then we will be able to start the next job. Once we finish job A, we will start job B on 25th day. Now it will take 16 days to complete job B. So we will be able to finish job B on 41st day. Once we finish job B on 41st day, we will move on to the next job. The next job in the sequence is job D, which requires 10 processing days. We will complete job D on 51st day since we will be able to start job D on 41st day, that is after the completion of job B. Next, we will start job C. Since job C requires 14 days to complete, we shall be able to complete job C on 65th day. Next, we will start job E on 65th day and complete this job on 77th day. In the next step, we will calculate the days past due based on the due date information which is available in this column. And if the finish date is less than the due date, days past due will be 0. So this is how we calculate days past due. Now for job A, the due date was on 29th day. Since we finished the job on 25th day, so days past due is 0. For job B, the due date was 27th day. But we finished the job on 41st day. It means we have days past due equal to 14. That is the difference between finish time and due date. Similarly, for job D, we have days past due equal to 3. And for job C and for job E, we have days past due 0, since the jobs finished earlier than their due dates. Next, we calculate the flow time by adding the finish time and time since the job arrived at the workstation. So we have the following information for each job in flow time column. Here we have the information about days past due and flow time for each job from the last slide. We will take the average of days past due by using the data in days past due column, and the average days past due value is 3.4 days. Similarly, the average flow time using the values in the flow time column is 60.2 days. And this is how we calculate average for days past due and flow time for job sequencing using first come first serve rule. And that's all for this video. Thank you for watching and see you in the next video.